Hello, and welcome back to Teacher Gimble's channel. Today we're going to be going over Illustrative Math, Algebra 1, Unit 1, Lesson 12. If you like this video, make sure to like and subscribe so I can continue making more of these. Let's get started. Problem 1. The shoe size for all the pairs of shoes in a person's closet are recorded. This person only has shoes that are size 7. What does the mean? Immediately, because all of the shoes are 7, I know the mean is 7. There is no deviation between the values. All of the values are the same, and therefore the standard deviation would be 0. That's it. We're done with that question. Let's go on to the next one. Here is a data set. What happens to the mean and the standard deviation when the 7 is changed to a 70? Now, because we're calculating a few different things, I'm going to copy my data. I'm going to go to statlet.com, which is one of my favorite statistics websites. It is quantitative variables because we're dealing with numbers, and I'm going to click on it, and I'm going to post our data. So here's my data. We're going to begin analysis. Now it automatically makes us a dot plot, which is nice. But down here is what we're going to look at in the summary statistics. In this case, we see the mean is a 4, and the standard deviation is a 1.651. So let's write that down. We have the mean equal to 4, and the standard deviation equal to 1.651. Now, what the question is asking us is, what happens to the mean and the standard deviation of the set when a 7 is changed to a 70? We're going to take that 7, we're going to change it to a 70, and we are going to fix the analysis. So go ahead, we did that. So when we've changed it, our mean is now 9.25, and our standard deviation is 19.175. There is a huge difference when we change that number. And one of the reasons for that big difference is that the difference between 70 and 70 is a very large difference. So it's going to drag the mean all the way to the right, bigger than any other values in the original data set. And it's going to create a standard deviation where we notice that all the data deviate or are a distance away from the mean. For the data set with a value of 70, why would the median be a better choice for the measure of center than the mean? Well, our median we know is somewhere around the middle. Even if we change the 7 to 70, our median is still going to stay somewhere around the middle. So the median, which is a measure of center, doesn't actually change when we change the 7 to 70 in comparison to the mean, which switched to 9.25, which is way bigger than all the original values of the data set. So the median, which isn't so susceptible to getting pulled by an extra value that's way different or an outlier, is not an accurate way of measuring center, so therefore the median would be better. Pause this video and re-listen if you need to write this down or think about this idea as we move on to the next question. Problem 3. Which of these are the best estimates of the standard deviation of points in a card game? So we have 500, looks like it's the mean. Well, it has to be the mean because this is symmetric. So we also have, are most of these, they deviate by 5 points, or do they deviate by 20 points, 50 points, or 500 points? Let's do a few calculations. So this deviates by 5 points below and 5 points above. Here we deviate by 10 points below and 10 points above. There are no data points that deviate more than 10 points away. That would have to be a value greater than 510 or less than 490. Based on this, the best option for standard deviation would be about 5 points. Maybe it would probably be a little bit more than 5 points because we have the deviations of 10, but given our answer choices, 5 points is most closely aligned to what we see in this dot plot. Let's go on to the next question. Standard deviation takes a little while to get the intuition, but the more you practice, the easier it gets. Problem number 4. The mean of a dataset A is 43.5, and the mean average distance is 3.7. The mean of dataset B is 12.8, and the mean average distance is 4.1. Which dataset shows the greatest variability? So when we're looking at this right here, the variability is measured by the mean average distance, and that means the average distance each point is away from the mean. This guy is smaller, which means each point is closer to the mean. On average, each point is only 3.7 away from the mean compared to 4.1 for dataset B. So in this case, the dataset A would be the one. Dataset B has greater variability. Dataset A has less variability. Dataset B, and that's because the MAD is higher than the MAD of dataset A. What differences do you expect to see when comparing the dot plots of the two data? Well, if we had greater variability, that means the dots are farther apart or farther away from the mean. So for dataset B, I would expect the dots to be a little bit farther away from the mean or the center of the data than I would see in dataset A. Again, pause this video if you need to take a second to write this down or re-listen before we go on to the next question. Select problem 5. Select all the distribution shapes for which the mean and the median must be about the same. So, must be. In this case, we're going to think about where does it have to be the same? Well, we know that in anything that's symmetric, the mean and the median are going to end up the same. So in a bell shape, we are symmetric. A bimodal could be symmetric, but it could also not be symmetric. So we can't assume that the mean and the median are going to be the same for the bimodal. A skewed is never symmetric. Symmetric is symmetric, so the mean and the median would be the same. In the uniform, all the data is almost always the same, so the mean and the median will be the same. And that would be our answer for problem number 5. Let's go on to the next one. Problem number 6. What is our IQR? I like finding IQRs from box plots because it is just this distance over here. So over here, this is 7, and here, this is 14, which means the distance in between is 7, and that's going to be our IQR. The reason I know this is my Q3, this is my Q1, this is going to be my min, this is my max, and this is my median. So Q3 IQR is equal to Q3 minus Q1, and in this case, it is 14 minus 7, so it is equal to 7. And we're talking about units, which are branches, which is why it is 7 branches. Let's go on to the next question. Problem number 7. The data represents the number of cans collected by different classes for a service project. So we have all of this different data. Find the mean, find the median, eliminate the greatest value 42 from the data set. Explain how the measures of center changed. So, since we started to use technology to calculate the mean and the medians, let's go ahead and continue to do that. So I'm going to put my data in here. I'm going to begin analysis, and we are going to look at it now. So our data, as it existed, we have the mean is right here, is equal to 18.5, and the median is right here, is equal to 16. So that is for our initial set of data. Going back to the problem, we found the mean, we found the median. Now we want to know what happens when we eliminate the value 42 from the data set. Let's see how the measures of center change. So we're going to go back to our data. We're going to eliminate 42. We're going to begin our analysis right here. And we see that the mean, in this case, for our new values, the mean is equal to 16.364, and the median is equal to 14. So what happened in both of these cases, when we got rid of the 42, our mean and our median became less. Let's go back to our problem to see what it's asking us to do. Eliminate the greatest value 42 from the dataset. Explain how the measures of center spread. So what we saw happen right here is originally our mean was 18.5 and our median was 16. When we took away the 42, our mean shifted down a little more than 2 points, and our median shifted down about 2 points as well. So the measures of center changed by becoming less when we took out the 42. All right, if you have any questions, you want to see more videos like this, please put them in the comments below. Let me know what you want to see, and I look forward to seeing you in my next video.